Hi, welcome back to our study of data science. So in this particular lesson, what we're going to do is go through some basic plots in Python, okay, which we're going to use in our data science because data science mostly is about visualization of your data to make insightful deduction from it, okay. So what we have here is we in plotting we have to use a different package. I know you are familiar with Python, sorry, NumPy by now. The next package you introduce is called Matplotlib, and this guy is actually used for plotting, okay, in NumPy, in Python, sorry. So from Matplotlib import pyplot. This is what does the plotting. Pyplot as PLT. That is a standard name we use for it. If you don't want it that way, you can actually call it in a different formats. Maybe from Matplotlib import star or something like that, and it will import all the plotting or everything, all other functions in Matplotlib. That is not good because it's going to call for other unnecessary functions. But here you can be specific about which function you want to use, and that is a pyplot for Matplotlib, and then we want to name it as PLT, okay? And then we import NumPy as NP. And of course, when you write all these, you have to run your code to get something, right? Now get it here, the data for plotting here, I'm generating an artificial data, or what I mean by just something I'm generating myself, okay? So this data is actually not defined or is not containing any message from anywhere. This is what I'm defining for myself, okay? So I want to define some two data sets, X and Y, and I want to call X to be this guy here, np.linspace. This linspace is a numpy function that actually what it does is it gives us a data set that is generated from linear spaced data points. Okay, so what I mean by linear space is it starts from 0 and it ends at 10, and we need 100 number of the point. It should be linearly spaced. What it means is the difference between individual data points should be the same, okay? And y is defined on x to be whatever y I get, I should be defined whatever x I get, I should define my y to be sine of x. And here we cannot just use sine because sine is a math function. Either we import the math module, which we don't want to use. NumPy can actually do all these things. So we just imported NumPy and say y equals np.sine sine of x, and that'll give us a y function. So what it means here is if I print, let me uncomment this and run this code. When I run this code, I get to see x. So this is actually x, right? We can say if I want to add other things to this, x is given by, then what I can do is this x, right? So we can actually do that, and if you run, we get to see x is given by, and you see that the rest of them here, right? So that you see that this is actually x. I mean, this part is not needed. You can actually just print x and see what it looks like, okay? So this is x. The data here we have is x. Y is going to, this is what y is going to do. When I pick x equals 0, the first entry, the first entry of y is going to be sine of 0. That is 0. Then you go to sine of whatever I have here till I get to sine of 10, right? These will give me the data point of y, okay? So if I print y, I should get a different data point, and sine of 0 is indeed 0. Sine of the other one will give me this, so it means that sine of 10 is negative 0 point something. I don't know, but I mean, these are the solution or the values we get for sine, the y, okay? So we can comment these guys out. We don't want to see the data. All we want to do is see if there is we can have a plot between x and y, okay? Two plots in this lesson, line plot and scatter plot. The line plot is needed if you just want to do a basic line plot. I mean, I will just do that and you see. And scatter plot is needed if you want to know if there is any relationship between two data points or data sets, okay? So how do I plot a line, or how do I give a line plot? The basic one we can do, we can actually do a lot of things to our plot. That will be an exercise for you after this lesson. I will just ask you to go and add more things to your plot, okay? So the first thing we do is we call plt, which is the plot, right? Dot plot. And what do we want to do? We want to plot x on the x-axis and y on the y-axis. So this actually is just a basic one. Sometimes we specify which one you want to put on the x-axis, which one you want to put on the y-axis. Here, the ones I've done here means that x, whatever I put on the first means is on the x-axis, and then whatever I put on the second is on the y-axis. Then I go to plt.show. So one thing is this: you can run this. Once you run this, luckily for us, we are actually using how do we call it, Jupyter Notebook, so it shows this plot. But if you are using any advanced plotting or maybe any advanced ID of Python, you wouldn't see your plot. You realize this line here that I have is in some square bracket. That is because I did not actually show it, but it just came anyway because of the fact that we are using Jupyter Notebook. But the ideal case is plt.show, and that would show the plot without the other one. Okay, so that is the traditional way of going. And this is a plot. If I see this plot, what happened? I can't make any deduction out of this. Okay, so one thing we can do is we can actually try to see if we can change the size. Okay, so we can try to change the size. plt.figure. This figure here is to say the figure size you want. Okay, and I want 8 by 4. You can actually try different ones. Like I said, I'll ask you to do different ones, and we can actually add a label to this graph. Say label equals maybe the sine wave. Sorry. Right, and then we show that we have to show legend before plt dot legend. Sorry. And then when I run this, I should see, right, so the size here has changed. At least we see the full graph. Okay, we can actually try to manipulate this to get maybe 5 by 4 to see a very small graph. That really makes sense, right? And the legend here, it has a name to this is the sine wave, at least, or the sine graph, whatever you want to call it. We can make this a 3 by 3, and then it will give us a very small square something that actually is appreciated, right? Because we get to see everything in here, right? The next thing we can do, maybe we can change this to 5 to 4, right? We can add a lot of things to this. We can add the y-axis. You realize that on the y-axis there's no name here. On the x-axis there's no name there, so we can put x labels and y labels. So plt dot x label, right? These are just normal English. You can say this is time if you want. Y label plt dot y label, right? And that is maybe magnitude if you want. If you run these, you should see magnitude on y label and then time on the x-axis. So you realize that things are changing, right? And we can give a title. We can actually give a title to our plot. plt.title, and we have line plot. Okay, of the sine wave, or maybe of the sine wave, right? If that's the case, we can actually delete the label if you want, right? Or maybe just line plot, because we have the label to be the sine wave. So we can run this and we have a title. So at least this, if somebody sees this, it makes a little bit of sense, because what type of plot is this? It's a line plot. What is on the y-axis is the magnitude, on the x-axis is the time, and this is a sine wave. So somebody gets to see that, oh yeah, this is actually a sine wave. If you are familiar with a sine plot, you realize that this is actually the sine curve. Okay, it's just that the data, you can actually change the data in terms of pi, and then you get something different, okay, or something nicer than this one. Then we go to the scatter plot that says, like I said, if you want to see whether there is any correlation between your two data set or data points given, then you use scatter plot. Okay. Again, I'm going to copy everything I have here. Okay. It's just that. So let me copy everything here. Go to the scatter plot. The only thing I change is instead of the plot, what I'm going to change here is scatter, right? And it just changes everything to the scatter plot. Okay, and here I'm going to change something to color, and I want the color to be red. Okay, if I run this, I should see something. Okay, this is a scatter plot, and you realize that this is just that the label, sorry, the legend is not supposed to be there. All right. Yeah. So you realize that the scatter plot is just points. You have dots, and it helps you to see the pattern or the pattern that your particular plot is taking. All right. It helps you to see the relationship between two data sets. You realize that, oh, this is the pattern that my two data set actually have. It means this may be one of the what do we call it, the trig function is either a cosine or sine. Then I have to figure out and do a lot of calculation to come up with the actual function that it represents. Okay, so these are some of the things we can talk about in plot. In our next lesson, we'll talk about bar charts and histogram and other things. Okay, see you in my next lesson.